So solve graphically. This is the given LPP to you. You know that LPP consists of three parts. The first part is the objective function. These two together called the constraints, and the last one is called the non-negative restrictions. Before solving the LPP, try to look at the nature of the constraints here. Both are of less than or equal to type. You may get the cases like either both are less than, both are greater than, or a combination of these two. Now we are still in the first part where the constraints all are of the less than or equal to type. The first step in this graphical method is nothing but consider how many constraints given to you. Two constraints are given to you. Let us take those two constraints, constraint 1 and constraint 2. For these two constraints, let us try to find out the ordered pairs for these two to represent on a graph. So here both are of less than or equal to type, either less than or greater than or equal to type. Try to consider those two as equations. These two are equations. First try to find out the ordered pairs. Take x1 is equal to 0. If you put x1 here, 0 plus x2 is 450, you will get x2 is equal to 450. Try to put another variable as 0, you will get x1 is equal to 450. On the whole, the ordered pair for the first constraint is nothing but 450, 450. Similarly, you do for the second constraint also, that is put x1 is equal to 0. What will be x2 then? x2 is 600. Again, you put x2 is equal to 0, then you will get 2x1 is equal to 600, x1 is equal to 300. So what is the ordered pair here? First you should write x1 value followed by x2 value. After considering those two constraints, two or more, by considering those equations and the equations, those two inequalities as equations, by putting one of the variable as 0, find out the other one. In such a way, find out the ordered pairs for both the constraints. Now to plot these on the graph, as we are using the non-negative restriction called x1, x2 greater than 0, the bivariate axis should have only in the first quadrant of out of the 4 quadrants. So let us suppose that x-axis stands for the x1 variable, x2 stands for the y-axis stands for the x2. So what are the possible values you can consider, scale you can consider here? You have starting value 300 to 400. The scale you can consider here as with 50s, let us take, which is nothing but you can start from 250 or 250, 350, 450, 550, or otherwise 350, 300, 350, 400, 450, 500, 550, 600. Similarly on the y-axis also, which is nothing but 250, 300, 350, 400, 450, 500, 550, 600. So you take scale according to your convenience. Here you took on x-axis 1 centimeter is equal to 50 units. On y-axis also 1 centimeter is equal to 50 units. What is the first constraint you have? x1 plus x2 is equal to 450 with the ordered pair 450, 450. Try to locate those 2 points here. This is also 450, 450. You join those 2 points to represent the first constraint on the graph. So this is the first constraint. So what is the nature of this constraint here? Originally it is of less than or equal to type. So shade the area towards the origin. What is the second constraint you have? 300 to 600. Here 300 and the other one here is 600 on the y-axis. Try to join those 2 points. You will get the second constraint. This is of constraint 1 and this is of constraint 2. What is the nature of second constraint also? Less than or equal to type. I hope you will get this is the region representing the second one. So if you observe, try to look this is the first constraint which is towards the origin. This is the second constraint which is also towards the origin. If you observe this will be the common area for both those two. The area which is common to all the constraints in the given problem is called feasible region. I think we observe that this is the feasible region for the given problem. So I try to identify the corner points, means boundaries of this feasible region. 0, we have A, B, C. O, A, B, C is the feasible region. Read all those points from the graph. O is origin, which is nothing but 0, 0. What is A here? A is O. This is A, B, C. What is A? A exactly at 350, 300. So on the x-axis you know that y value is 0. A will be 300 comma 0. Here this is the point B. So try to locate. I am taking approximately. So here you will get approximately 260 or around like that. Here B against B have a point 260 or somewhat like that 260, and here it is 400. Maybe these points, if you do on the graph perfectly, you will get the exact points here. C is nothing but on y-axis we know that x is 0. So x1 is 0. Here this is nothing but 450. After reading all these points, you calculate z. What is z? Z is nothing but objective function. Z at O. What is z here? Z is 3x1 plus 4x2. You place the corresponding values. Z at O is 3 into 0 plus 4 into 0, which is nothing but 0. Z at A means 3 into 300 plus 4 into 0, which is nothing but 900. Z at B 3 into 260 plus 4 into 400, which is nothing but 3 into 260 is nothing but, wait a second, 3 into 260 is 780 plus 1600, which is nothing but 2380. What is Z at C? Z at C means 3 into 0 plus 4 into 450. 4 into 450. Which is nothing but 800. So as the objective function is of maximization type, from all these available values, you should consider the value which is maximum. So we observe that Z is maximum at, what is the value here? X1 is equal to 260 and X2 is equal to 400 with Z is equal to 2380. This is the case when all are less than or equal to type. Okay, thank you.